Hello, how's it going?
All right.
Okay.
Oh, hello. Yeah, sorry, I was talking with mute on.
Oh, me too. I was doing that at first too. So I have two things I could share, two notebooks, two different things. However, we don't have to do that all today. How about yourself, Suji? You got anything lined up?
No, actually, we just finished our search summit, so I was pretty busy throughout. Yeah.
You just finished your what?
We have an internal conference called
Oh,
Search Summit.
uh-huh.
So it's basically, so we are a bunch of companies, right? So all the companies, the search professionals, we kind of come together and, do presentations and, talk to each other and talk about what we've done and so forth. So that's basically what we did mostly.
Anything interesting out of that?
Mostly, I was impressed with how Lexis has become a very data-driven company, right? So our problem with search mainly is evaluation. It's very hard to evaluate. You need domain experts, and because the search corpus changes, whatever the domain experts come up with is ephemeral, right? It's not. We cannot reuse that. So they have figured out a way of reusing their data. Well, first, their data doesn't change as often. Case law is, case law. They do have new dockets coming in, but it's not like, it doesn't change at the rate of medical information, right? Or research information. So their problems are slightly different, but they have managed to. So what I found was, about 2 years ago, they came up with something called Search Test Framework, which basically was a tool for them to, have their human experts validate offline the search results, right? So, given a query, so they would look at the query logs and say, okay, given a query, this is the query that has happened. Now let's run the query ourselves and see if the results are good. And if not, what re-ranking should be done to make it better. And what I was struck by was that they have taken that data set and the data sets that spin off from there. So one of the spin-offs was they moved to an online model. So now they're using actual clicks and dwell time and so forth to actually figure out engagement. And they're comparing it with their human model, and they're seeing if there's any correlation. Also, they're taking the data itself that they have collected and using it for other things, right? So they're using it for one of the nice things was the zero results problem, right? So if you have a very overspecified query, it doesn't match everything, so it gives you zero results. And the other option is to now, break it up into entities and OR them up so that you get, something. But then you have these irrelevant pieces of the query. How do you get rid of them? How do you prune your query, basically, right? And so those were two ideas that I thought was, really cool. And I like their approach is, when they tell you something, right? This is what we did, and this is how we measured it, and this is the percentage gain we saw, right? So that kind of, we don't have that, right? So that was something that I really liked. Then there is the obvious things like, graph stuff and vector stuff. Like
Well,
we have
when you say we, you're talking about
Elsevier.
Elsevier versus Lexis?
Yes.
So Lexis is getting the modern search bug where they're actually quantifying stuff and adjusting. Well, congratulations. I know when I was at Reed, they had no idea of anything quantitative. You know what I mean? Yeah. They didn't even understand their business in any way. Like the web products, what were they? They were not. They didn't know what features and what sites were making them money. Nothing. It's freaking ridiculous. So that's pretty cool.
How do you determine that? Let's say you have queries. You have stored queries. How do you determine if they were good or not?
Well, what do you mean by good?
So if user was looking for something and they
so the offline method is basically having domain experts like legal guys, right? Basically looking at the query and saying, okay, this result is relevant, this result is not, right? So it would be mainly like, somebody looking for a case, or there's somebody looking for a legal kind of opinion, right? So what happens if a man bites a dog, for instance, right? I'm making up a ridiculous thing. But are there any precedents, right? So you would have that query. They would look at the query from the logs, and basically, queries are often repeated, right? So at least in health, it is very common to see repeated queries. So they would look at the high frequency queries and try to see if the results that they are surfacing are good. So that is the offline side. On the online side, you basically have, again, it depends on, how well you know your, the user behavior that your group of users show. So for example, they have something called, how long does so when the user gives a query, does he click on any of the links? If he does click on the links, does he stay on it for some time, like, or he just exits out immediately? And then there is also something they call shepherdize. It's basically like a guided query kind of thing. So does he get into that, right? And finally, so this was something that we talked about with them earlier, because we are trying to get there as well. So one of the things that they ask the user, like, did we satisfy your query? Because if somebody gives a query and then exits immediately, it could mean one of two things: either that they were terribly unhappy with the query, or they're super satisfied with the query, right? They got everything they wanted on the first page itself, so you're done. So things like that. And so you ask the user, right? So was this a successful query experience for you? And then they try to correlate that, with the actions that they see. And using that, they determine the rules for, by which they would measure engagement.
Great, thank you. Because reason I'm asking is that we want to start doing something like that, because we have results of search, but I don't think anybody thought, and ours is very simple, so it should be like much simpler to do, but I don't think we thought of like how to score them ourselves, other than look at it, what you call offline.
Yeah, I think that was the biggest piece of insight that I got. So essentially for health, one of our domain guys, he's our domain expert, the chief domain expert. He's got people under him. So he basically raised this issue. He said, we are throwing away a lot of data, leaving it on the table kind of, because, we would like to use, see how engaged our customers are by looking at their clicks. So that's when I basically got them connected with LexisNexis, because I knew they were working on that. So I was in one of the meetings, and that was the biggest piece of insight I got, the ask the user. Not all users are going to say, tell you what they are doing, but a lot of them will, right? So, and then you can take that session and correlate their actions with their, the success, whether they succeeded or failed, right, in the query.
When you say ask the user, you mean a pop-up box or a phone call?
No, a pop-up box.
Okay.
Yeah.
So I had a question about what you talked about there. The I'm going to call it query rewriting for the overly specified queries that produce not enough results or whatever. Did you have any ideas about how that might work?
So one of the things that our, like Elsevier did research tech, they basically ran an entity recognizer on top of that. So what they noticed is that a lot of times when you come to Science Direct or Scopus, people are actually pulling in citations from some other paper, right? And those citations have a nice format. It has a title, it has year, it has author and whatnot, right? And even, the journal name and stuff like that. So what happens is, because with Science Direct, you are trying to do title search. It was equipped with title search. It doesn't find it, even though the title is in the query, but you've got more stuff in it, right? So you got, like some author name 2022 or 2021, and, journal of whatever, like it's all added in there, right? It's a full citation. So the idea was that you run an entity recognizer over it, and you try to isolate these things, the pieces. And then this is the same thing, well, very similar thing that I did with the insurance company in my last job. So you basically isolate all these pieces and then you run, so then you say, okay, I found a title. Now, using the title, I will do a title search and use everything else as facets, right? Because I've identified that 1999 is a year. So I can do pub year for that. The author name, I can see, I can, try putting that in. So those are like optional features that you can also put if, in case you get results. So, you try to do your best with that. And if you get 0 results, you start dropping stuff. Like, so they had a way of figuring out the relevance of each piece.
Sure.
They kind of went like very light on that. So I wasn't able to understand what really they were doing.
Yeah. So let me see. I kind of got what you said. So are you saying, first of all, when you say title search, is the person doing a fielded title search? That's the
No.
Okay. Then when you say title search, I understand. What you're doing is you're extracting NER, you're extracting entities from a failed query string, and then you're using that. I guess I don't understand what title has to do with that, but you're using that to query documents that have been classified to those entities, like you're doing a linking or entity linking, or you're actually searching on titles using those entities. Is that what you mean?
Yes. So essentially what we have is a title search, right? Searching by title is a huge part of our functionality, right? Because a lot of people search by the entire title of the paper, right? They know the title of the paper.
It's all abstracts. I mean, it's all you have is title and abstracts, right?
Yes. But my point is that, unlike other searches, which are, ands and or terms or whatever, one of the things we try when we get a long piece of text is match it up against titles, right? Because chances are it's a title. So, and that is one of our big features, right? So, that's what we use. But now if you give me a citation which contains the title, because I'm, taking the entire thing and sending into title search, I cannot do it, right? I don't find anything, I get 0 results, which is, a stupid thing to happen, right? Because I've already given you the title. Why can't I get?
I'm sorry. So let me just make sure I've got the foundational piece here. The foundational piece is when you say title search, it's me, the user, trying to find an exact title.
Exactly.
Unknown title. So it's a known title search.
Yes. And
okay.
We anticipate that, right? We anticipate that, and we basically have a component which does title search, specialized for title search, right? Internally. So
is the customer checking a box saying this is a title search?
No.
Okay.
No. So so basically then we just split it up into entities and then identify the title in there, do the title search, and use everything else as facets, right? That's basically the gist of the idea. And then depending on if we still get 0 results, we start dropping the facets depending on how important they are. I think it's a rule-based thing. So they would drop the author name first, maybe, or the year then, right, and so forth. And so that's the basic idea, or the journal name, because sometimes the journal is like abbreviated in a different way than what we would expect, right? So yeah.
Interesting. I wonder if LSH deduplication a little loosened up might do it.
Could be, yeah. And actually, I mean, a lot of the problems that we see kind of stems from the one, box query that Google has popularized, right? Google gets away with it because of its huge, their huge corpus size. Plus, they have people working on this like, full time, right? But so there was another demonstration yesterday where they took a very specific domain for litigation, right? So, and for litigators, all lawyers are not litigators, right? So there is apparently a subset of lawyers who are litigators, and they do very fact-based kind of searches. So what these guys did was they, replaced the single box with a bunch of boxes, and at different levels of specificity, right? So if you fill up the first box, you don't have to fill the other 3 boxes, but you can if you wanted to, right? So they'll give you like kind of almost like faceted search, right? But it's kind of guided search, right? And they give you like stats and so forth. So it's actually a pretty cool idea, and of course it's it's an idea is kind of going back to the beginning, I guess. But it's basically like advanced search, but with very domain specific, right? So you target it to a specific domain of users, and then you just work with that. Then you don't have to do any entity recognition or nothing, right?
Yep. Interesting.
Yeah, so it was fun. I mean, a lot of ideas. Some of them are old ideas. Some of them are new implementations of old ideas. Some of them are new ideas. So yeah.
Yeah. How about yourself, Yuri? You got anything you want to talk about or share?
No, not today. I was maybe next time. I'm trying to like finish something, but I wasn't able to finish today. I wanted to. Oh, actually, I want to ask two questions. So we have on the mapping side we have models that do the mapping, but we always wanted to do generation of new ontology, right? So run generational model that if we cannot do mapping, we basically don't have those ontology on the right, can generate it automatically, similar to the rules on how we do it. So we tried using GPT-3, and it works okay, but our biggest problem with GPT-3 is that you have to give it a lot of examples, and the prompt have to contain, like, if GPT-3 is not trainable, so it understands analogy, but because we have a lot of different things in our ontology, you have to give it a lot of examples for this specific mapping to work. So like if it's in this subdomain, you have to have examples from that subdomain. So so prompts have to be big, and it's expensive. It becomes expensive. So we started looking at using free alternatives. So this is my question. I've seen in the news the like GPT-3 alternative called AI-21. I don't know if you have any experience with it.
I did see an open source one. Have you seen that though? That might be true.
You mean GPT Neo or J?
Yeah, I think.
Yeah.
Yeah.
They actually just released J, which is Jack's implementation.
No, it's neither of those, but it's an open source. I heard the guys talking on podcasts, and they basically, it's not as big, but it's using the architecture, and they're working their way. Maybe I'm, yeah, but it's probably trainable. Well, I did before Suji respond. I didn't quite understand what you're doing. Can you're taking a term from your ontology and generating?
Oh no. So we are. So the task that I've been working on, and where we work on mapping, is we want to integrate data from different data sources. So each data source has its own sort of key language of the keys, right? So we want to map those keys into our keys for the database, which is basically our ontology. So people have been doing it manually. That's very expensive and error prone. We started doing it automatically with NLP. But right now we can only basically, if let's say we didn't have apples, somehow we never work with apples, and we only have bananas and melons. So we can try to map, but it will tell that it's probably a banana or a melon because there's no apple. We can tell that distance between apple and banana is pretty big, so we can not suggest this mapping to the analyst. But then we have we haven't mapped apples. So what we want to do is automatically create new ontology entity called apples. But it won't be just apples, but it will be, let's say it's apples. Let's say it's Granny Smith apple packaged in 3-pound bags. We want to generate it according to the rules how our ontology is structured. So the name should be like following exactly what I said.
So in a way, from a graph point of view, and I'm not saying you should take this point of view, but from a graph point of view, because I've been thinking about that lately, it is it's a node prediction. Like you're actually filling in, you're generating nodes. You want to generate ontology keys or terms. I get it. I think that's
yeah. I thought about it as I was like looking at different graph classes. I was thinking about it, but it's very complex to think about it as a graph prediction, because then our graph needs to contain sort of everything.
Well, it would be no. It would be. I have seen something on this, but again, I'm not suggesting this is developed to a point you could use it. But generative, there are graph generative models. I think so they will generate just like GPT-3 does, but they'll generate new parts of your graph. But anyway, I understand your use case now. So yeah. You're trying to use. So I'm not very familiar with prompts, but you're trying to use prompts with GPT-3. So give me an example of a prompt or two that would.
Prompt is like prompt is just you give it an example, and it replicates it with the data. I haven't done it much, so I can't tell you what it is. I just looked at it.
I mean, from an apple, by the way, Granny Smiths are horrible. Let's talk about Fuji's instead. I love Fuji's.
Okay.
Yeah. But so if you didn't have a specific type of Fuji, like some special heirloom Fuji, right? What would the prompt look like for that?
Okay, so let's say your database that we're trying to bring in says like Fuji Matanzan. I don't know. It's in Spanish. But in fact, like it says Apple Fuji, or it's Apple, Fuji, or I don't know. Some, but for us it should be Fuji apples, organic, organic. So what we give it, if we give it, banana, organic banana have to map into banana / organic, and we give it enough examples, then it will learn how to, given this like left hand side, given the prompt, it will learn how to generate right hand side.
That doesn't seem to be a very difficult problem, though, right? I mean, I'm surprised that you need a lot of examples.
No. But like, let's say this one doesn't need a lot of examples, but for if we don't want to do anything specific for this new source, if we don't want to create examples for new source, I think that's when it needs to, or the source has a lot of data that's not exactly like, it's translated, it should be translated similarly, but it's not from exactly from the same domain. So it has a couple of variations. Basically, all the possible variations have to be covered by examples.
Well, I mean, I've seen GPT-3 in action, like on somebody else's Zoom screen. Usually we did some question answering, and with 5 examples, it was actually able to do quite a good job of question answering, even cross-domain. So, it may be possible to take a look. I mean, I don't know. I mean, whoever did this, maybe the examples were not. I don't know. I mean, we didn't actually even do much work for, or at least the guy who showed us, he didn't seem to do a lot of work for getting diverse examples. It was like 5 randomly, random questions and passages, questions and answers. So questions and passages, I think.
Mm-hmm.
Yeah, so it was questions and passages, and you get an answer. So yeah.
Yeah, I might go back. The other thing is we run out of free tokens, so it was like I think it's more like a psychological thing. Like we were ready to buy some tokens, but then the person said, no, well, I think I want to. Well, first her idea was maybe try GPT-2 first, which I thought we should try GPT-3 first, and then when it works, then we can always see like if it works with like a great tool, then we can step down and see if it's still good. But we haven't done that yet.
Yeah, so before GPT-3 became popular, right? Everybody was talking about it. So I tried T5, and T5 needs training, and at least 2-3 epochs of training before it can, start working reasonably well. So GPT-2, I think, would also be similar, I think. Anyway, so
yeah, GBTJ is the one, right?
Oh, that's the one you thought about?
Yeah, I think so, because Ethereum, those are the guys.
Yeah.
Yeah. Anyway, yeah.
Anyway, thanks. That's a useful. Yeah, this kind of reminds me. So I was last week. I was judging Penn State AI competition, and it was actually really good this year. So it was really difficult to score. But and it has to be in the areas of education, sustainability. I don't know, like health. So they do projects, but a lot of them actually building companies around them. So when they graduate, they already have work experience. It's kind of interesting thing everybody does now. But there was a reason I thought about it. There was one group that they used like 4 or 5 technologies, like in their like a process. I think they were trying to do either like psychological help or like find. It was basically like a conversational bot that was trying to send people, like give them different resources. But what kind of surprised me, they no, I think maybe a lot of projects were similar. I think maybe they were extracting information from it. But anyway, so they used all possible NLP technologies. They used like BERT for like a smaller classification task. They used XLNet for something. They used GPT-3. They basically, like, for different like sizes of their application, they use different networks, which I thought, on a small project was overkill. But I think they just wanted to try different technologies.
I mean, I've kind of done that in a, with the Word2Vec stuff I did with using it as a classifier. Basically, I use like 3 or 4 different keyword extraction technologies, right? Completely different ones.
No. But then that's the thing. Like for every part of the problem, they use different network, and
yeah,
it was. But it was, for like small project, that was interesting.
Yeah.
I don't know how well it worked, but yeah. I think that's. There's one more thing I wanted to. I just saw a new technology. Have you guys seen Gradio?
Gradio, yeah. I haven't seen it. I've just heard of it, and yeah.
Radio or Gradio?
Gradio, yeah.
It's like Streamlit.
Yeah, it was really funny that somebody at work asked about Voila, which is previous like a kind of a Jupyter Notebook visualization and interaction framework, like web framework, and it was used by FastAI last time, and it was okay, but I don't know. It was I thought it was a little flaky, so I told them like use Streamlit instead, and then I saw that actually now FastAI has used Grade.io as in the next iteration.
Okay.
So.
And Grade.io, they seem to be very ML model centric, right?
Yeah, this is and it's on top of it, like voila. It's basically you just add one line to your notebook, and then you can have web component and interaction. So you can like build website out of notebooks.
Yeah. Nice.
All right, that's it for me.
Yeah, thanks for that. That's cool.
I had a question for Streamlit.
Uh-huh.
So I'm trying to expose Streamlit through Nginx reverse proxy, and it seems that I had a bunch of other issues where so I was showing media images. So Streamlit basically takes the image from memory and then gives it out on /media, right? So whatever the thing /media, and then they have their own like a long random number string with JPEG. So they make up these names dynamically. So I fixed all that. Now I'm getting like a static, right, a JS file, and that's not that's just coming in as /static, right? So so essentially what I've done in the reverse proxy is that anything from 8501 they get changed, and they become like the IP address, like localhost 8501 changes to whatever internal IP address I have, and then /clipdemo, right? And so this, so essentially if I do /clipdemo on the static, it'll show, right? But it doesn't, and I have no control over the JS file because it's all Streamlit driven. So I'm wondering if you know of any configuration parameter that would kind of signal to Streamlit to do this internally.
God, I have no idea. That is way beyond me. I mean, I don't even really know what a reverse proxy is. And then, yeah, what you're talking about. Yeah, can you give me just a teeny bit of context in terms of?
Yeah, here's the bug I raised. That has a lot of the context. So essentially, here, I'll just put it in the chat.
By the way, I did have one network issue, probably completely different than what you're talking about, but that was, they don't have a way to configure timeout for the server.
Mm-hmm.
And so I put the server in, I put my Streamlit app into GCP, open it up, the URL, and I could hit it, but because I was on satellite internet, this is when I'm up in Washington State, the delay was too long. And so it would show like it was rendering, and it would just never render. And then eventually give me some sort of non-response code. And in fact, when I'm up there, it happens to like half of the Streamlit applications out there in the world, right? That, I was looking at demos and things. So they're supposed to be adding
Okay.
for that. But that doesn't have anything to do with what you're saying, I'm sure.
Well, I mean, this one is mainly because, how Streamlit, so I'm running the Streamlit app on the AWS box, and I don't have a browser on it. So I do local port forwarding to get it on my local thing. But now I want to show this demo or allow this demo to be used by everybody, right? Everybody within Elsevier. So what I have to do here, basically I put a Nginx reverse proxy on top of my, on that machine. And essentially it forwards localhost 8501 on its own port 80, which is open within the VPN, right? And with like port 80 / some name, right? So I chose clip demo, so it will become like 10.1. whatever / clip demo is, it will bring up my Streamlit app. So And then, within Nginx, you have to basically tell him that, here are the things that have to be changed. And that's what you'll see if you go to that bug or the Streamlit discussion thing, right? You'll see this, yeah. So,
yeah.
it basically says proxy pass 127.0.0.1.85.0.1, right? So that becomes, yeah. So
you can't just make this, just make the URL publicly available.
No, I cannot. That's
That would be nice.
Yeah.
Yeah. So, but where this file sits is not. This file is not sitting in the Streamlit app. This file is sitting on the.
It's the Nginx configuration. Yes.
Which is something that's an AWS. That's the reverse proxy. The AWS.
No, Nginx is basically Unix, but yeah, I mean it's a reverse proxy.
It's sitting on, but it's sitting on the VM. So this is a configuration sitting on the VM, and it's not working. The question is, are you feeling like that's a Streamlit issue, or is it a AWS issue?
So what I did, no, it is not a VPN issue. Well, yesterday it worked for some reason. Today it didn't. I'm not sure what happened. And I haven't changed anything, right? So that's the weird thing. But today when I was looking at it, it basically says that if you go down, like I opened up the developer, because Streamlit is all JavaScript, right? It's a big hunk of JavaScript. And so I opened up the developer console and I saw that, the main Streamlit data, that's my stuff, which, that is being loaded fine. But when it tries to load this JS file, the 6.8 ddd10a.chunk.js, that's where it gets 404 not found and, aborted. And now if I change it to, so obviously this is not going to get through the reverse proxy because it's a /static. So actually, maybe I can open up /static as well. Maybe I can do that. Okay, I'll try that. But if I change it to the clip demo /static, which is covered under rule 1.2, the second rule, right? Second location thing. So if I do that, it shows up, right? So I will try, opening up static as well to see if I can get something out of it.
Right, so maybe like a hierarchical thing where you have to keep opening up deeper if you keep going deeper.
Yeah. I'm surprised though. I mean, I initially thought that Streamlit had changed for some reason and they were no longer, supplying this because it worked yesterday. Why wouldn't it work today? But anyway.
Did you upgrade incidentally? Streamlit? They changed Streamlit. You didn't upgrade Streamlit.
I did not upgrade. No.
Yeah, because they changed so quickly. Who knows?
Yeah.
Okay. Well, I'm glad at least you came up with an idea.
yeah. I'll try this. Just opening up static by itself.
Now you make me feel better. So they say with machine learning and data science, you spend most of your time on data. I love working with data at the same time and manipulating it. But you know what really drives me crazy is how, and I still like it, but I hate it. It drives me crazy the sort of ops stuff.
Yes.
And you are so deep into that. I'm just glad I'm not there.
Well, that's the problem, though. I mean, I find myself spending a lot of time trying to demo stuff, right?
That's your organizational support problem.
Yeah, true.
It is, so that can be a huge problem. I'm having the same problem, not this level, but basically I have the proof of concept, the audience builder, I've called it. I've kind of talked to you guys and showed before, but I'm actually sharing it across the company, kind of randomly, bottom up, and getting feedback. And people are quite interested and excited about using it. And I've promised the URL, but I put it on the GCP VM, so it's not on my local machine, but I can't access it even when I'm on our VPN because our ops guys have to do something with a GCP and it. So luckily, though, we have this guy who's really good. In about 2 weeks, they're going to upgrade the way they deal with networking on GCP. So I think I'll be in luck. But so there's no control. I mean, I'm going to have to stick it all on my own GCP, which is fine. But then I don't have access to our BigQuery data, so I can't do some of what So it's like stuck in a conundrum, man. But anyway,
yeah, we have a very similar issue, right? So I'm trying to use from, although the issue is within the, within the groups. So, on health, even though I'm kind of consulting with them, they won't give me a machine to run my stuff on. And in labs, I have a machine to run my stuff on, but no access to their APIs. So
yeah, it's the same thing. You figure if there's 3 people on this call and 2 of them are having the exact same thing, it's an industry problem. Somebody needs to try to solve. There's a
exactly, yeah.
business there, maybe. I don't know, whatever. Okay. I guess I'd like to show something simple, and then maybe you guys are doing the graph course and everything. Maybe you'll be able to answer a quick question I have. Okay, guys?
Sure.
Okay, so let me see if I can see what I can do here. Hold on. Let me see if I can get the right page up. Is that it? I'll do the graph one first. So let me see if I can share that. Where is the graph? Graph. It's terrible. It shows you all these little screens that I can't identify which one's the right screen. It drives me a little crazy. Okay. So do you guys see? Let's see if I can make this bigger. Yeah, you see linked web page crawler?
Yeah.
Okay, so let me tell you what I'm doing here. All right, so this is a piece of code I stole from someone and then adjusted to my needs. Okay, and this is I don't know why I have two, but see these are we have what we call our search sites, which are just sites of IT content our editorial folks have created. And that's the sort of foundation of our business, these sites, these editorial sites, and activity from those. So what I want to do, when I was sharing my proof of concept, like I just explained, I also am learning about people's businesses, right? So I was talking with the editorial director and her assistant person, whatever. But anyway, they happen to explain a completely different use case, an interesting use case they might use the word of audience builder stuff for. But then it made me think that this is a graph problem, perhaps, and it's kind of interesting. So I haven't talked with anyone about this, but I started playing with it. And the idea is I crawl, see this is called search custom experience. Okay. Search customer experience, is, a bunch of marketing, MarTech content on market technology and so forth. And I don't know how many thousands of editorial documents there are on there, but when they create a new editorial document for SEO purposes, evidently it's critical that they identify inline text within the editorial that they could link to other editorial within our search sites. Okay? It's like we're interlinking all of our editorial and we're doing it to improve SEO, but we do it one document at a time. So it's the editorial process, and it gets written, it gets copyrighted, all that, not copyrighted, but copy edited and all that stuff. And somewhere along that editorial workflow path, they're also having to figure out, I think it's the writer who's doing it. They have to figure out inline linking. So within the text that links to, and you don't use the title, you have to use language fluidly, and you just link to other editorial content. And you think we have like 300,000 documents that we've written over the years, so it's kind of hard to find, good documents to link to, right? And if you do find good documents to link to, which is the optimal one, right? And then you have to, it's even harder to find, you have to do when you create editorial documents, you have to find other documents to link editorial content to link into this new editorial document you created to help drive traffic to. Okay, so that's really hard. How do you find other editorial content that's similar and it makes sense to link into ours and then do all that? So we just had this very simple sort of large network of interlinked networks. So it's a homogeneous network, right? And it's a homogeneous content network because each node in the network is a document. So what I did is I crawled. You see these pages I've crawled? This is
right.
count 151. Then I actually found 151 links in it to other editorial content in our sites, not outside of the network, just internally. this probably, I mean, I don't know what kind of pages, it's not really, that's not an editorial page, right? Like you could see that's like landing page, that's the home page, right? The next one is news, but you start getting into editorial as you go along and the numbers drop a bit. But so I'm collecting the links. So that's the data I have, right? For each page, node is a URL, right? It's a page. And for each node or URL that I crawl, I then find all of its links. So that's all I have, right? Like a dictionary of URLs with a list of the links I found.
Right.
I go within the link. And so I go, I grab network X, and what I try to do here is I create, I guess I call this the index file, because a lot of, they do that a lot, right? So there's, it's a dictionary in the reverse order you would normally see, but it helps me look it up. But so there's your node IDs, and here's the URL. Okay. Then I munge this in. So then I look here and I convert the, the links for a node.
Back to a series of links. Okay.
Yeah. So they're all IDs out of that index. And then actually what I ended up doing with network, so I was putting it in I guess, edge format here. But then I realized I could just use their, GML.
Right.
You somewhat familiar with that?
No, but NetworkX has a lot of formats
that
it takes.
So they have their own they try to proselytize. And I don't know if you guys can see when I open up a new tab. Do you see a new tab?
I see Google. Yes.
Okay, so let's look. So it's just a markup language for loading. See, there it is.
Oh, I see. Okay.
And then it is
very cool.
And then it has edges. So for some reason I decided I would use that. So so I just put it into that format and load it, okay, which is great. And it's only a small amount that I loaded. And obviously my graphing skills at this point suck, my visualization, right? I need to up my visualization game. But I just showed that it would render my graph. I'm doing 10 pages with all their links. I don't know if these make much sense or not or anything yet. So I haven't really done that, although I think they'll be quite interesting and informative. You could even see like finding hubs, or I don't know, there's going to be all sorts of interesting things in here. But my first intuition was do link prediction.
Okay.
Right? So link inference. And so once I get this in here, I want to be able to say, hey, here's some links we don't have, but maybe we should. Let's review them. So the idea is, instead of doing this one document at a time, we could try to optimize our network for SEO linking. So it's sort of like you're seeing really the germ of that project or idea. Now, the first thing I ran into is this. So you see how I do, oops.
Ran out of RAM, I think.
Yeah. Okay. No. I just ran out of idle time on Colab.
Oh, I see. Okay.
But you see what happened there?
Strongly connected components. Okay.
So first of all, the first error I got trying to do this with Network X is that it's a directed graph.
You can wrap it in a digraph. So when you create your graph, you have nx.graph at some point somewhere. Just call it nx.digraph instead. That should give you a directed graph.
A what graph?
A digraph, di, small I and capital G, and digraph, directed graph.
Oh, yeah, no. But when I loaded it, I set the directed graph flag in the markup language to 1, which means it's directed graph.
Okay.
And then when I
not implement for directed type. I see. Okay.
Yeah, so they don't implement for directed graphs.
Yeah.
So I mean, maybe I need. I don't know how important that is. I think I'll undirect it and then try to infer anyway.
Yeah.
Directions do matter, but anyway, in general, my point was not. This is just where I got to because I didn't have any more time.
Right.
I guess my point is that. Do you guys have any thoughts or ideas on that germ of that idea of our, and graphs? And I mean, obviously there's a million ways you can go with this once you have this in place, because it's an easy fit for doing embeddings, even doing, message passing embeddings and sage graph and all of that, right? Because it's just a content network. So each each node I could represent as a embedding space, right? As a vector. And like, it's pretty easy to adopt examples. But what do you guys think about that? Any ideas or thoughts or brainstorm?
Link prediction would be nice. I mean, you could consolidate your current setup with better links or more links. Other thing you could do is for new documents as they come in, you could think of it as a search problem. So each of the linked pieces, right? Those are candidate keywords, right? So you could, given your content and your candidate keywords that you find, you could train something that will look in your new document for keywords, find them, and then you could do searches on your corpus using those keywords, and whatever top result comes in from that, right, you link it to that.
So explain, I lost you right at the beginning. Where do these keywords come from? Are you talking about the anchor text for the link?
The anchor text, yes. Ahref, right? So those are your candidate keywords. Like humans have picked those things and, said that these are, things, right, that we can link from. So you can use that and maybe train some kind of keyword generator, like maybe what's that called? Kia, and the other one, Kia and the other one that is better than Kia. Or you can train autophrase, right? And then you could run the train model on your new document and extract keywords from that, and then use those keywords and basically search your corpus, right? Using those keywords, and whatever it picks up as the first one, you could put in as candidate links for this new document. So this is for new documents.
Yeah. So yeah, that's the outward linking
right.
idea. So, but Kia, right? So I get the idea that you have. So you're saying train the auto phrase or Kia or whatever
to predict keywords from content.
So is it to predict keywords from? What I mean is, okay. So you have the anchor text.
Mm-hmm.
You extract keywords from that to train your model?
Yes.
And what are you training? So what's the input for a model when you're done with the model? The output.
So for training the model, you would take the text of the document and the anchor links that you have extracted from the document and say that,
okay. I get it. You're training it. You're training it to predict documents given.
Predict keywords given a document, yes.
Okay, predict. So you give it a document, you get keywords, and then you're using those keywords to formulate a search. Is that right?
Yeah, you're breaking up. I'm not really sure what you said because I just heard part of what you said.
Can you hear me now?
Yes.
Okay, so you're using the keywords that you've predicted with your document to keyword prediction model, and those keywords you're formulating into a query?
Yes.
You run a query, and so when you say query, you mean like a normal keyword?
Yeah, Lucene based, yeah. Lexical query.
Yeah, I actually can almost do all of that already because the Word2Vec model I extract keywords right from documents, and then I search the Word2Vec space, and I'm able to get documents or keywords or topics.
Okay.
The power. I think what's interesting you bring up is the power of the anchor text in this now.
Right.
It definitely has a role to play, right? Because it's such a highly curated semantic representation of the document.
Yep.
Okay.
I have a question. How are you predicting links now in this? Like I didn't see. I just saw how you generated graph, but like where do you actually use NLP?
Bottom of the page, he's starting, I think.
You see the link predictions equals.
Okay. Oh, so what you? But I thought that. Strongly connected components is just extracting some subgraph.
Yeah. I don't know. I don't know if. Yeah, it's if you look at the documentation, I can't remember why. That's a funny name for a function, right? That does so basically I've screwed something up in this. You're not seeing what I actually called. Okay. If you go to the NX library, they have a method. So I've screwed up the text here, Yuri, right? You could ignore what's above there. Now the link prediction NX dot you can keep, right? So,
okay, got it. So we haven't seen it yet. Got it.
Well, it's supposed to be here, but evidently I changed it and messed around. So, but if you go to the Network X stuff, they have under their section called algorithms, they have link prediction algorithms, a number of them, okay? Like neighborhood based. So,
why do you have a dot before the?
yeah, so this text is screwed up now because I was trying to figure other stuff.
Okay, all right.
It should be something like, Jacquard, neighbor,
Okay.
link prediction. I don't know what they call it, right? And then with the whole graph in. So you just stick the graph in there and it gives you prediction.
Okay.
And if you go to Network X, they have algorithms for that. Okay, so Network X documents. I'll go there real quick so you guys can see, because it took me a while to figure out how they organize their documents, their documentation. But so under algorithms, you see that on the left?
Yep.
They have a ton of algorithms, right? And I think let's find link prediction. There you go. So there's link prediction section. Okay, so you see those different link prediction algorithms?
Oh, I see. Okay.
There's the Jacquard, Adamic, or whatever, however you say that.
Mm-hmm.
That's a very well-known.
Named after Lara Adamic.
And I've been watching the Stanford videos, and he actually, in the one I just watched, talks about these, right?
Right. Yeah.
Why the Adamic, I think it's global.
Yeah, there are different properties. I think I forget what they are, but different kinds of random graphs. But
you just feed the graph in there, and you feed the graph in there, and it'll do it, right?
Yeah, exactly. Yeah.
There's a bunch of these, so it's kind of interesting. I'm trying to get to the point where I can really see what comes out of it. Does that answer your question, Yuri?
Oh yeah.
Okay. Any other general thoughts or brainstorms? Just in general on the whole thing. There's also the inbound linking. You want to find documents. You want to add links to the link to your new document. There's also just the general idea.
Actually, sorry. No, that doesn't answer my question. So what does it take as an input? In order to predict link, you need some properties, right? So typically we think like some sort of, NLP vectors or something else. Or
I get it.
Or here pure like graph kind of. Are there
these are all pure graph stuff. There's nothing to do with
they call it topological.
Okay.
So it's using just the graph. There's no.
So it's just like a similar. Your friends.
Yes.
Your friends are friends, so you should be
exactly
friends.
Yeah.
Okay.
It can do more than that, but it's all based. There's no attributes. There's no vectors. There's just, for the node, there's just the topography of the graph surrounding the node and so forth, right? And it gets kind of sophisticated because it predates, having the ability to do the vector type of stuff, right? The embeddings and message passing. So it's not quite that simple. Which they explain in that Stanford lecture, but yes, this is all these so far. I'm starting. So if you want to, I'm starting with the simplest thing, right? Neighborhood topology kind of stuff. Then it would be nice to figure out, wow, can you put attributes? I don't even mean vectors, right? So like maybe there's amount of activity that a certain page gets, right? Can I have that as a node attribute? And then can I use a couple of these, node attributes in doing link prediction? I don't know, right? That's what I'm trying to learn. And then the question will be, well, I actually have documents. I could use, SageGraph or whatever and do some, ML kind of stuff rather than this sort of old school ML. Yeah. Does that give you more?
Yeah.
And if you're looking, so for the next step, when you go there, once you have exhausted the topological stuff, you can do things like transy and complex. Those are like embedding based link prediction things. And I had, I'll post it once I find it. There is a library which gives you these training loops for free, right? They're built in, you just have to instantiate and call it. So you can create transy vectors. All you need is your, the original embeddings of your nodes, right? And the data structures connecting them. And you should be able to, generate transy vectors out of that.
What kind of vectors? Spell that?
There's different names. So one of them is called transy. So I like that best because basically it says that, if
transy is a capital.
Yes,
It's like
yes, exactly.
Big PRANS, big. Right. So go ahead. Why do you like those?
Because it's so transy is very translational, right? So it basically says that subject plus predicate would be equal to object, right? So if you do vector math, you can do that, right? And you could then take, subject 2 plus predicate would be equal to object 2, right? So you would be able to, given a subject predicate vector, you will be able to now apply it to multiple. You just change the subject and it will point to a new object, right? So, and that will be your predicted link.
Yeah, I get it.
Let me find your.
What do they call those? What do they call those type of algorithms, like the transy?
I think they're called embedding relation, or relation link prediction. I think something like that.
So in a way, what they are is you generate from your graph. You take your embeddings, whatever they are, that represent your documents in your graph, or your, what deep and wide, whatever your vector for your, tabular data. Either way, you have a vector, right? For each.
Right.
And this then, the transy, what it does is it creates another embedding space that's optimized.
Yes.
For
relation extraction.
It's funny, I've never heard of predicate. The only time I've really heard of that kind of predicate logic is with word to vec, the king and queen, kind of stuff. But no one ever uses that for anything.
Yeah, that's probably not very useful. So here is the thing. It's called PyKeen. So I'm just going to paste it here.
PyKeen. Oh yeah. No, I know PyKeen because you talked about it last time.
Yes.
Ah, that's cool.
Yeah, I have to actually use it myself, but this is good too because I'm thinking of doing a relationship predictor based on our ontology. So thank you for this one, the algorithms. I didn't realize that NetworkX had these link prediction algorithms as well.
I didn't realize. I heard him talk on I heard a podcast, and I did not realize that it's been around a long time.
Right. Yeah.
And so probably it's a good space for more of the old school algorithms, although not having directed graph capabilities is a lot. But yeah, I mean it's alive and well as an app. I think as long as you don't need to scale, they can't scale yet.
Exactly. Yeah, it'll take a long time to do.
Scaling means millions, so I mean I'll use it just to learn, right?
Right.
And see if it doesn't scale. Unless you guys feel like I should be using a different base like Neo4j. You have to pay for Neo4j, right?
No, you don't.
Really?
Yeah, the community edition is free.
Is it? I mean, right now, what I need is something that's easy to use and clear, right? Not. I'm thinking maybe Neo4j is much more. I want to be able to quickly start learning these things. Do you think Neo4j is more convoluted? More
Neo4j has a learning curve.
That's what I'm asking about. Yeah, no curve right now. No thanks. But are you saying that it's worth it at some point? That's probably the next step once I exhaust my.
If you're going for scalability, depending on if NetworkX is okay for you, right, for your purpose, then it's fine. Otherwise, you'll find that at least for medium-sized graphs, Neo4j has much better performance. So I just posted the link prediction algorithms. You'll find that there is Adamic, Adar, common neighbor. So there is some of the common ones, a subset of what Neo4j has. But you could run these, and I suspect they also have examples on how to do it. Yes, they have examples on how to do it as well.
Yeah. Is there another core library like that, or are those really the two to just?
There is Snap, that's C++ based, or one other thing you can check is CuGraph. CuGraph has, it keeps the NetworkX API, but it runs on GPU, so it's much faster, like 20 times or faster.
Can you say that again? I couldn't get.
CuGraph from the Rapids, NVIDIA Rapids thing. Hang on, let me post it.
Yeah.
Rapids CuGraph.
Yeah, Rapids.
It's based on GPU, so you would.
Yeah, it's just hard to use in Colab, so it's hard to.
Yes, not on Colab. You'll have to have your own GPU box, I think, to do it.
Yeah, that is.
It makes Colab is kind of it's possible, but it makes it hard to do.
Right, but the how about in your own VM, GCP VM? Then probably it's not so bad, right?
It's not so bad. You can install it and.
And what was the one before that?
Snap. Snap is from the Stanford people.
Snap. Oh yeah. I've seen.
It's C++ based, and it has a slightly wonky API, but it has a lot of algorithms supported. I'm not sure if the the link prediction ones are there, but knowing that it's managed by this guy Leskovic, I would think it does, because he's an academic and he's pretty complete. He's kind of the authority on graphs nowadays.
Yeah, no, I get it. That's good. Nah, I mean, I think I go with Neo4j first unless I had a reason, because I don't want to use something that's Java underneath. I don't have to. Kind of like a Java. Right?
Neo4j is Java underneath.
Oh, is it? Ooh. Okay, well, it doesn't matter.
You won't see it. I mean, it's just yeah. Well, you will see it when you install GDS, but that's about it. GDS is a jar, the Graph Data Science library. Basically, a jar doesn't come, built in with the community edition. So you would have to pop it in and then, make some changes and config and so on. That's pretty much it.
All right, guys. Well, that's graph for me. So I guess maybe we'll both evolve a graph thing. Link prediction was with predicting what sorts of links.
This is very cool. Yeah.
What were you thinking about in terms of your link prediction problem? What was the context there?
Context is mainly for ontology maintenance. I'm actually not sure if plain old link prediction is where we want to go. I think the main focus is reading literature and discovering relationships that are new, right? So when COVID-19 came up, read all the papers and find relations between the ACE2 inhibitor protein and the SARS-CoV-2 virus, right? So that didn't exist in ontologies because SARS-CoV-2 was not discovered yet. But as the literature comes in, you start grabbing these things. So I think it's more in that sense, very similar to your discovery idea, right? Where what happens to a new document? Get all the links from a new document. It's kind of similar to that.
Well, I could see that being really powerful in the big picture if you had a knowledge graph for COVID, which actually Sean Grant, remember maybe you weren't here yet, but we had a guy present in this forum.
Okay.
He basically pulled in. So the point is, if you have a knowledge graph which was pulling in data from publicly available data sources or internally, right? And by knowledge graph, it's a heterogeneous graph, right?
Right.
And those are and the node types are entity types, right? There is specific, and if you have that, and then you do your entity extraction in your content, right? And then and try to get links from there or whatever you can, and then link that into your knowledge graph and suck it into your knowledge graph, right? So you have those two sources for nodes and links.
Right.
then if you did link inference, well, first of all, you probably have a bunch of links. You probably just have a bunch of links in there that are new anyway, right?
True.
Not technology, because they're combining structured sources with unstructured, right?
This tends to be, we tried that. So it tends to be a bit noisy. So that's
Oh,
why
yeah.
people don't like it, right? There's a lot of cleanup required at the end. So,
But couldn't you validate the relationships from your knowledge graph coming from your database against your content? Like use those as a...
yes, I mean, we could, but then the additional stuff that is predicted, right? You don't know how much of that is good, and that's what you want, really. You know, how much of that is good and how much of that is like noise, right? So then you have to have people go through it and clean it up. So that's the basic downside of it, right? Using it without...
The noise is coming from relationship extraction directly from the text or from the database stuff?
From the text.
Right, but the database, what's going to happen is the database stuff
Cleans up, right? So the database contains all your known relationships, right? So you pass it through a whitelist, and you're left with only stuff that you already know about, right? Whereas what you actually care about is the stuff that the database does not have, but the text has. But you still don't want it to be so much that it's hard to work with, right? So you want that little slice in the middle, minus the noise, but whatever is not contained in the database. Yeah. So that's
okay. Yeah. Okay, guys, that's all I got. Anyone have anything else?
I have nothing. No more. Yeah.
Thank you.
Sure. All right.
Great. Thanks. Talk to y'all next week.
All right. Talk next week.
Bye.
Bye.